Hi, my name is Julie Lochner. I'm a Senior Analyst and Vice President for Data Management Solutions here at ESG. Today we'll be discussing the results of our lab validation of the EMC Greenplum Data Computing Appliance, or DCA. The IT landscape poses eminent challenges for those responsible for data management. ESG research recently identified managing data growth and improving data analytics as the top two IT priorities. When combined with attempting to complete data analytics tasks with traditional processes, tools, and technology on a larger and larger data set, aka big data, IT teams are presented with new challenges. And with flat or shrinking IT budgets, how can organizations control the amount of time, money, and effort it takes to load large data sets and process simple to complex analytics? All this while scaling the underlying infrastructure, planning for the future of bigger data. EMC claims that the Greenplum DCA was built to address these challenges. The DCA is a purpose-built, highly scalable analytical database appliance that combines a multi-parallel processing, or MPP database, compute, storage, and network into a single, easy-to-manage system for big data analytics workloads. Stating that the DCA can 1. Ingest massive amounts of data, 2. Scale linearly as data volumes grow, and 3. Meet performance expectations when conducting complex analytics, we traveled to the EMC Greenplum engineering facilities in San Mateo, California to find out if what they advertise is true. For our tests, we used an out-of-the-box DCA GP1000 loaded with 5 years of real-world detailed transaction data equating to 10 terabytes or 50 billion rows of data. First, we tested how quickly the DCA could consume or ingest a new batch of data. Then we added compute and storage capacity, measuring how much better the DCA performed. And then we tested the system's ability to complete the most complex analytics. We timed how long it took to load 800 gigabytes of data, which is approximately 1 year's worth of retail transactions. And we confirmed that our configuration could ingest almost 5 years of historical retail data in about the amount of time it takes to grab a bite to eat. Once the data is loaded, organizations want to know how well an analytical database system will scale as new datasets become available or additional analytics are required. We ran a set of benchmark queries before and after we expanded the GPA1000 from 3/4 rack to a full rack. With 25% more compute power, we saw the queries return on average 25% faster. Without having to reload the data or take the entire system offline, we were able to confirm that the DCA performance does scale linearly. Finally, we wanted to see how well the Greenplum database performed with complex in-database analytics. Using a complex 14-stage predictive model designed to mine several tables for data for the most potential high-risk customers, or in other words, to predict customer churn, we looked at almost 2 million customers' behavior patterns, with the results coming back in less time it would take to grab a cup of coffee. So we set out to prove that the EMC Greenplum DCA could do 3 things: ingest massive amounts of data to meet near real-time analytics requirements, scale up and out to take on ever-growing data volumes, and meet our performance expectations for complex in-database analytics. The ESG Lab team validated EMC's claim that the EMC Greenplum DCA is built from the ground up to handle the most punishing analytic workloads. And all this and driving productivity from every angle. So now the business can focus on results big data promises to bring. And we tested all of this in a day's time. If you'd like to learn more about the data model we used, the GP1000 testbed technical specifications, or the detailed test results, you can read the report freely available on both EMC and ESG's website.